This presentation provides an overview of Chapter 7a in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Iman Hakiki and Thomas Hurdle, and published by Springer. In this chapter, background is provided on the behavioral parameters underpinning the world regions represented in Simple G, which are inherited from the non-gridded simple model. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover a portion of Chapter 7, which is on behavioral parameters, capturing geospatial heterogeneity in economic decisions and responses. This chapter follows on from the three prior, which laid out the mathematical representation of the Simple G model, as well as the underlying data representing these regional economies. We'll start by taking a look at consumption parameters. We'll then move on to the production side of the model, and we'll wrap up by exploring the trade parameters. Consumption parameters in the model include the income and price elasticities of demand for crops, livestock, and processed food commodities. Income elasticities represent the percentage change in per capita demand for a given food type, in response to a 1% change in per capita income. Price elasticities of demand represent the percentage change in per capita demand, in response to a 1% change in commodity price. In Simple G, consumption elasticities are linked to the log of the per capita income for each region, to capture the impact of dietary upgrading. Non-food commodity demand is obtained as the difference between per capita income and food commodity expenditures, therefore income is fully exhausted on food and non-food spending. Production parameters in the model include input substitution elasticities, which govern how easy it is to change input mix, in response to changes in relative input prices. Input elasticities of substitution for the crop and livestock sectors are calibrated based on historical simulations. For the processed food sector, fixed proportions between inputs and outputs are assumed, so no input substitution is allowed. Production side parameters in the model also include input supply elasticities. In the non-gridded version of Simple G, cropland supply elasticities are based on regional parameters from the EPA model developed at MIT. Non-land supply elasticities are based on the GTAP AGR model. And non-crop input supplies in livestock and processed food sectors are perfectly elastic, such that these prices are exogenous to the model. Note that for other versions of the model, sources of input supply elasticities could differ. In the non-gridded version of Simple G, cropland and non-land supply elasticities are adjusted to their long-run values using long-term own return elasticity of cropland in the U.S., taken from the work of Ahmed, Hurdle, and Lubowski. Armington substitution elasticities measure the degree of substitutability between imported and domestic goods, which are taken from Hurdle, Hummels, et al. In that study, the average elasticity for crops is around 3. This is applied to both import substitution and export transformation elasticities. These estimates are subject to uncertainty, and sensitivity analysis is encouraged. Here, you'll find additional readings and references you might be interested in further exploring. On this slide, you'll find the link to the Simple G webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 7a. We encourage you to explore the other companion videos that accompany the book on the Simple G webpage.